Okay, hi folks. Once again, welcome back. And the topic for this brand new session is operators in C. And before starting the session that is called operators in C, let me give you a brief description why we use operators in C. We use operators in C just to inform the C compiler to perform such kind like perform logical or mathematical manipulations. All right, so for that purpose we use operators. All right, and you can see there are a list of operators that you can find and you can perform it in C programming language. And the first one is, let me start with arithmetic operator. And these arithmetic operators consist of this many, that is at least five important operators, that is a plus sign, minus sign, multiplication sign, that has like a star sign or divide sign or a modulus sign. All right, so each has their own purpose, and this is totally related to arithmetic. You can see that addition operator adds two operands. You know, what we are seeing here is like we are declaring a data type, any kind of data type you want to uh, manipulate, and we manipulate two or three or many data types, and as a result we get a new data type, a data type with a new value. So this is the main purpose. This is the mathematical manipulation that is done here. So you can see there is also another operator, that are increment and decrement operator. And increment and decrement operator are mostly used for integers. All right, so you can see that plus plus increments or increases the integer value by 1, whereas minus minus decrements the integer value by 1. And also there are some relational or comparison operators. These just compare two kind of data types. Okay, compare in the sense like compare according to the size, or compare according to the value. So relational comparison is also possible by using a relational comparison operator. Whereas you have the logical operators like and or not. So also you have the bitwise operators, that is and, that is just the keywords are just here. Okay, so whatever I have provided here are just the keywords, that is the um, that is used in C programming. So and or XOR, left shift, right shift, ones complement, everything. All right, whereas also bitwise operators are mostly used for bitwise comparison. Okay, so while you are performing the manipulation with respect to bits of uh, the the integer value, okay, that you want to perform. Now you have lastly the assignment operators, which takes two operators and operands, and there are the left operands and the right operands. So whatever after manipulation, the result is stored in the left operand. All right, so this is the way how it is used. And now you have the ternary operators, that is like you have the expression here, and which is evaluated. If it is true, then you follow this expression. Okay, expression 1. So on comparison to this expression, if the expression is true, then you okay, if true, then you execute this expression 2. Okay, otherwise if false, you have to execute this expression, that is expression 3. Alright, so this is called ternary operators. And the conditional operators are mostly used in the conditional operators are mostly used to check the condition of that expression. Alright, if and else case, switch case. Okay, I have an example that gives you the implementation of all these operators. So let me go through the example. Here I have provided you an example which follows the similar pattern or structure that I described in my beginning lecture, right, about C program structure. Now what I have done here is I have defined two data types, that is the integer data types x and y, with its respective, I assign the respective value, that is 8 and 2. Now what I do, I try to show you the arithmetic operators, okay, how they are performed. So printf, you know the printf function x plus y. Right now first initially I am trying to do is how x plus y. So what is the value of x plus y? Here will be this. So after performing this operator, the value will be stored here. Or you can also perform this way. You can declare int z equals to 0. Initially z is 0, then you can say z equals to x plus y, then you can directly put the value of z here. Okay, also this can be done, or directly you can also use the operand as an expression, and directly you can print it out. So and here the second one, I print out x minus y, whereas x divided by y, and also x multiplied times y, and also x modulus of y. And the idea of using modulus is very tricky, because okay, let me explain you what is the use of modulus. Modulus is whenever the x, if it is divisible by y, and then it returns true. Okay, if it is divisible, it returns 0, that is true, 0 or true. Okay, otherwise if it is not divisible, it has to return 1, that is false. So it's like, is it divisible or not divisible? Okay, either is odd number or an even number. Such kind of situation is performed here. Alright, and and this one is for incrementation and decrementation operator. Incrementation and decrementation, or decrement operator you can say. Yes, so after incrementing, right now the value of x is always constant, that is 8. So after incrementation operator plus, you increment the value of x by 1, like by adding 1 value, right? So that will be done here. Whereas you decrement the value of y, the initial value is 2, you decrement it by 1, that will be here. Okay, and the value is printed out here. Incremented, decremented. Alright, so after that, let's go to the relational operator, okay, with conditional operator to compare two variables. So these were the variables, right, that we declared of data type, integer data type. So I want to just compare it by using the conditional operator and check the relation among them. Okay, so if, look, I use if condition here, and I say that if x the variable is greater than, this is a greater than operator, if it is greater than y, then you can say that x is greater than y. Okay, and if it is less than y, you have to print it out x is smaller than y. If it is greater than and equals to y, so that means the number are same, then you can say, you can print it out is x is greater than or equals to y. So this is done here. And whereas you can also say that is x is less than or equals to y, and you can print it out by saying that x is less than but is also equal to y. Alright, and you can also use the equals to operator, that is comparing these two operators, I mean operands, like these variables, if they are totally equal, so that means x and the value of x and the value of y must be same. So this is to check that kind of operators, whereas if they are not equal, then this is printed out. Alright, so otherwise nothing is printed out. You have to be also careful about this thing. Either if in this condition satisfies, then the block signifies that within this condition check, if this condition check is true, then this action is performed. Okay, so you have to be also careful in this fact that this condition check is to only let or go the execution or run the execution only in the case that this condition check is true, otherwise nothing is going to happen. Alright, so after this relational operator check, now let's go to the logical operator checking or comparing two or more statements. And you can see logically, you know, there are three logical operators, that is AND, OR NOT. So also logical operators are usually used in while doing the conditional check. Okay, that is by using if and else statement. So let me go through this logical operator implementation. And here in logical operator, two or more than two statements can be compared. Before you could only compare only one statements, right? So either this statement, this only one statement, the condition check was okay, I could execute this printf statement. But right now I'm trying to execute two, I'm trying to check two condition check, that is two or more than two conditional statements are checked here, and you have to so if this conditional check is passed, then you perform this particular action, that is to print out that this conditional check is true, whereas else you say that this conditional check was not true and it is false, right? So the basic idea about using the logical operators are you can simultaneously check many condition. Okay, x is greater than y and x is not equals to y, and x is you can say that if x is equals to y, but okay, so you can check multiple condition check, but you have to be careful that in the AND case both of this statement has to be true. So this means this statement has to be true, that means it must return 0. Okay, and also x is not equals to y also must return 0, that means it must be true. Okay, so you have to be careful in this fact about using the AND operator, and this is a logical operator. Now there is a second conditional check that you are going to do is, and it is for OR operator. And for this OR operator is in this condition is that when one of the statement, if it is true, then you can print out the statements or run this statement. Otherwise, if both of them is false, then nothing is printed out, right? So this is the concept here. For OR, both one of them must be true, but for in case of AND only I mean both of them had to be true, right? So in case of OR only one can be true, and it's going to run the statement. Alright, so otherwise you say that it's false. Alright, and if is not this statement, so if this statement is not going to run, so if not this statement, then you print out this kind of statement. Alright, so else you do not else you print that the statement is not true. And last but not the least, I am trying to this is not the last one, but okay, let me go out. And there is another. This was just about using the logical operator. We will just run it and I will try to show it. So I will show you directly after running it. Now let's go to the bitwise operator. To implement the bitwise operator, what we have done here is we have defined an unsigned integer. Unsigned means those numbers which are positive numbers. That means it includes the numbers from 0 to the positive numbers. So if you check out I initialize the value of a, the integer value variable a as 60. Okay, so if you check the bit value of 60, that is 00111100. Alright, so also for b, I initialize the value 13, and the bit value of 13 is 0001101, right? And I initialize c as 0, and right now I do the bitwise implementation. Alright, so after doing the bitwise implementation, what I say is c is initialized to a bitwise and b. So that means what it is going to do is it's going to do the bitwise implementation. So and means both of them has to be. So if you go and check out only the bit value, okay, both of them has to be 1. So when is the situation that if you check it in this format, like okay, you just check it in this format, from this format and this format. So when upside and downside bit value must be same, that means only these two cases, that is 1 1 and 1 1, upside and downside are are same, right? So in this situation you can say that both of them are 1, otherwise those are not 1, those are 0. So this is the bitwise implementation that is done here. And after you can find the value of this bit value and this bit value in the decimal, binary to decimal format, it results to 12. Alright, and similarly for OR case, bitwise OR case, the value will be like only one of them has to be 1, and you can say that, like immediately you can say that this one is 1, this one, this one, this one, and this one, right? So you can say that you can see here that this bitwise is performed here, and you can see the result, that is 61 after converting the binary to decimal. Now there is a XOR operator, that is both XOR operator. It means that if the condition that both of them are 1, then you have to follow it as a 0. Okay, and if also both of them are 0, then you have to follow them as 1, I mean 0. So in this situation is like both of them are 0, those are 0, both of them are 1, those are 1. But if only one of them is 1, then you can use it as 1. So this is the XOR operator, and you can see the value will be 49 here. And similarly you also have this ones complement operator. So the ones complement of a, the value of a was 60, so ones complement of a 60 will be minus 61. It's just shifted by one step. So you can see that one's complement means both 0 is converted back, 0 is converted to 1, 0 is converted to 1 here, and 1 is converted to 0, 1 is converted to 0. So it is just like one's complement is just like is doing the inverse of this binary number. So just you replace 0 with 1 and 1 with 0, and by doing such you can get the bitwise, I mean one's complement. Alright, also there are some shift operator, like left shift operator and right shift operator. You shift by 2 bits, so you shift. So if you want to shift A with 2 bits, then what you get is like you just shift it by 2 bit, so this 2 bits will go outside, like it goes out of the range, and these bits will be shifted here, and so 1 1 will come here, and also 1 1 from this position will go to the respectively 5th and 6th position. Okay, so you just shift the position and you get the value here. Okay, and also right shift is also done here. This was for left shift. Right now also we can do the right shift, and by 2 bit, after doing the right shift, you get the similar different value, that is a 15. Okay, this was all about the bitwise operator. Now okay, let me explain you something about the switch case. Okay, that is a conditional check. And in this assignment operator, that is also as a I'm providing you both the assignment operator. I'm describing you more about assignment operator, whereas I'm also giving you the procedural implementation of switch case. Okay, so what is done here is like you have defined or declared a value, that is D, that is initialized to 3, and you declare a character sign, that is a multiplication sign. So what it does is switch case switches the sign. So among all these provided sign, if the sign matches the sign that is passed as a parameter, that is the sign that you have initialized. Okay, I initialized sign variable as a multiplication. Okay, so I pass this value as a value in switch. Then I compare among all these cases, I compare which of these cases matches the parameter passed. So it must match this parameter, right? So it will try to execute this particular statement, and let's check what is the statement. And I have provided here the assignment operator. Okay, so I am trying to implement the assignment operator here. So what is the purpose of the assignment operator is there are two operands, that is D and A, left and right operands. So what is done is like you take a left operand, that is D, that is 3, so you multiply D, the left operator, with the right operator, that is A. A must be something that is what is the value of A? Let me check. Yeah, the value of A was 60 here, but later on the value of A gets changed. Maybe it gets changed to, but anyhow we'll see the situation. Maybe it's A is 16. Okay, so the value of A constant is 60, so A will be multiplied 3 times, that is D, and the value will be stored in D. So D, if you print out D here, you will print out the value after the assignment operator. Alright, and then do not forget to use break keyword here, just to break this case. And lastly, if none of the case matches, then you have to also be careful about you including the default case. That means if the parameter passed was something that was not to be checked in this case, then you have to perform this default case. That means this is the default case, nothing matches. Alright, this was about the assignment operator. Now let's go about the ternary operators. So what happens in a ternary operator is like you are using the ternary operators to do the conditional check, and the first statement, that is x is greater than y, is done here. Okay, so x is greater than y, right? So if the conditional check, this is the first statement here you're checking, and x is greater than y, then this returns true value. That means x, what is the value of x? X is always 8 and y is always 2, so that is true. So that means you have to run this statement, that is the first statement here. Okay, so x is greater, this statement is run. Otherwise, if this statement check, that was x is greater than y, was false, maybe x is 2 and y is 8, so there is no other way that x can be greater than y. So in this situation you have to print this statement, that is x is not greater than y. So for this kind of purpose, okay, for this kind of conditional check, we use our ternary operators. That is three statement, like statement check plus it acts like something like a if and else, both just included with each other in one statement. Okay, and lastly I return 0 because my main functions returns an integer value, and I guess everything is perfect. So let me compile and run it. Build and run it. Yeah, after building the program and running it, I get the following values. So you can see the value of z becomes 10, that is 8 plus 2 is 10. Obviously x minus y is 8 minus 2 is 6. X divided by y, that is 8 divided by 2 is 4. X into y, that is 8 2s are 16. X modulus y is 0 because it's divisible, that means it returns true. Alright, so x is incremented, that is 9. Y is decremented, that is 1. X is greater than y, obviously, yes, and x is greater than or equals to y, obviously. X is not equals to y, obviously x is not equals to y. X is 8 and y is 2, right? So the statement of n is true. So this is the statement, that is x is greater than y and x is not equals to y. So in this sense you can say that x, the statement of AND is true, and the statement of logical check, that is AND, is true, and logical check OR is also true, because I said that x is greater than y or x is not equals to y, and both of them are true. So the statement of not is also true because x equals to y. X is equals to y, no, it's not equals to y, right? So after that, let's go to the bitwise operator situation. And for the bitwise operator, you can see the value of a bitwise operator and b is going to return you value of c, that will be 12, and this is written here, value of c is 12 after doing the operator, because you can see I did a bitwise operator between a and b, that is a is 60 and b is 13. You can also write here something like a and b, the value of c is there, a mod bitwise operator, or b or a one's complement or complement a, shift a is shifted to 2-bit, shifted by 2-bit, a is shifted to 2-bit to the left, and this is shifted to right. So overall this is the situation, and you can print out the respective values here. Yes, and lastly, with the assignment operator and using the switch case, I can see that it printed out this statement, that is D is multiplied to A, and the value is stored in D. So if I print out the value of D, it will print out 180, right? And lastly, yeah, you can also see the value of ternary operators, that is the conditional check statement x is greater than y, it returns true, and this statement was printed out. So if we want to check it, recheck it again, so let's say that x is less than y, it's false, so this has to print out. Okay, so let me close this, let me build and run it again. Yes, x is not greater. You can see that when the conditional check was false, this was printed out, that was x is not greater.